So our goal in this unit is how do we draw these without a graphing calculator? We drew all of those with a graphing calculator. Our goal is just like with y equals mx plus b, where you learned that b was the y-intercept and m was the slope, and you can graph any line quickly if it's in that form. We're going to want to graph parabolas quickly. And the main difference from this unit from last unit you were really concerned about solving quadratic equations when one side was equal to 0. So if I made all of these zeros, all we looked at in the last unit were these points. This one has 2. How did we solve with the quadratic formula and with factoring? We're going to find out that what we did in chapter 3 is a specific point on the graph, the x-intercepts, sometimes also called the zeros of the graph because they're where the y value is equal to 0. So some things to highlight. If you turn to 251, because we introduced a y to the equation, we call this a quadratic function. And a quadratic function has a general form, y equals ax squared plus bx plus c. This general form is very similar to our general equation that we use for our quadratic formula as well. Some parts or some more terminology. We call the shape of a quadratic function a parabola. And a parabola always has a highest or lowest point. That highest or lowest point is called the vertex. Vertex. And that'll be considered the most important point of the parabola. We're always going to want to try to find that vertex. Because once we find that vertex, we're going to get an axis of symmetry, which I already showed you before. That always cuts your graph in half. And parabolas are always symmetrical. You could reflect them over the axis of symmetry and get the exact same point. So some things that can kind of be like pattern recognition. If I told you on this graph that I had the point, I don't know, 1, 8, and then I also found out I had the point 5, 8, that tells you where the axis of symmetry is. What would the equation of this dotted line be? It would be x equals, if it's symmetrical, what would the x coordinate be of your vertex, and what would the equation of the axis of symmetry? So as soon as you find 2 points that have the same y value, right, they're going to be equal distance away.
Would the axis be 3?
And then the axis of symmetry in this case would be at 3 because it has to be cut it perfectly in half. So you're like, what's right between 1 and 5? Perfectly right between 1 and 5 would be 3. And then that would tell you your vertex is 3, something. You would know that the x coordinate of your vertex always matches up with your axis of symmetry. If your x squared is positive, so here it says when the coefficient of x squared is positive, it opens up. When the coefficient is negative, it opens down. So if you have an x squared graph, your parabola always will go up. You'll be in charge of making sure you always have arrowheads on the end of these graphs to show that they go up forever. So when it goes up, then your vertex is always a minimum. When it goes down, then your vertex is always a maximum. Does it make sense that your domain of a parabola is always everything? Domain are the x values. Is there any number you're not allowed to square? There's numbers you're not allowed to square root, but you can square a negative number, you can square decimals, you can square fractions. So your domain, and that's with these arrows, it goes forever to the left and forever to the right. Your domain is everything, but your range depends on the vertex. So for example, if this vertex was at 5, 1, then my range would be y is bigger than or equal to 1. Because you see that you have all the y values bigger than 1. Here, if this vertex was 3, -2, then your range would be y is less than or equal to -2, because it includes everything less than or down from -2. So your range is going to depend on the position of your vertex. So the vertex becomes the most important point all the way through. So let's go to example 1. And we want to graph, so I'm going to set up my graph here. And early on, the only thing that you can help you graph is a table of values. We're going to learn a bunch of techniques to make this even better, but we're going to start with a table of values. One number I always like to plug in a table of values is 0, because it's usually really easy mental math. If I plug in 0, I get -6. Okay. I got 1 point. What do you think? Is this enough to draw a very accurate parabola? Probably not. Okay. What we want to find is the vertex. And if we can find 2 x's that give us the same y value, we're going to find that symmetry. This might take us a while. So we're just going to keep plugging in points and see where we go. Okay, probably next I would probably pick 1. 1 seems like pretty easy mental math to do. 2 times 1 plus 4 is 6, minus 6 is 0. Okay, so I have a second point. This actually will give you right now a hint of where the vertex is going to be, using one of the things that we had in our notes so far. We know that because the number in front of the x squared is positive, this is going to be a parabola that opens up like this. And from this, you should be able to tell me, is the x-coordinate of my vertex positive or negative, based on the 2 points we have already? So if you're thinking your life is going to be easier, so based on those 2 blue points that we have already, and the fact that we know it opens up, you can tell me that the x-coordinate of your vertex is going to be positive or negative. Okay? So, here's these 2 points. If it's opening up, can it go like this? No. So if it's opening up, it would go through here, it would have to, maybe like that, that's a possibility, which would mean that this vertex is somewhere in the negative. But I don't know where it is yet. But as far as picking my next point goes, some of you would have probably picked 2 next. It's not going to be very helpful to go more in this direction. They're just going to get higher and higher. I want to find that vertex. So maybe I test out -1. If you plug in -1, this will be 2. -4 is -2, -6, -8. Okay? I should probably label these points on here. What happens if I plug in a -2? We haven't found symmetry yet. So another thing, if you're making a table of values, you are going to want to keep going until you get a y value that repeats itself. Now if I try -2, -2 squared is 4, times 2 is 8. 4 times -2 is -8. Look at this. We get -6. We have found symmetry because we now have -2, -6. I have a y value that's the same. And if these two are the same, that tells me my axis of symmetry has to go right on there. It also tells me if I found 1, 0 and it's symmetrical, I'm also going to have -3, 0. That's 2 away from my axis of symmetry. It'll be 2 away on the other side. And I now can draw my parabola through these points and have an accurate graph. My vertex is -1, -8. My intercepts, or my zeros, are -3, 0, 1, 0. Coordinates of the vertex, -1, 8. We didn't label our axis of symmetry yet, but we can. We'll do it in red. Draw it with a dotted line. If you have a red pen, you could take it out to do that. X equals -1. The domain is always everything, and the range of our function depends on our vertex. So you can either write your range this way, y is bigger than or equal to -8, because the y value is -8, and we have all the y values bigger than that. Or you can write it in interval notation, -8 with a square bracket to say you've included that, up to infinity, and infinity always has a round bracket. So remind you of set notation and interval notation for domain and range, which you did in grade 10 as well. We're going to do that a fair bit in grade 11 and grade 12. And questions you can circle, 4, 5, and 7.